Let's look at our second question of the exam revision. Now, our second question is also quite a demanding one. Now, this is taken from the September 2018 examination. Now, please bear in mind, remember I discussed with you this earlier. This here is extremely important. I explained to you what the shareholders of the company get at time little t, which is your starting time, can be valued as a call option with these parameters. Okay, in your using these parameters in your payoff. So your K will be your L, and your S sub T, which is the share price, will be the total value of the company at that specific time. And I explained to you how to value the bond holders. Okay, it's not just a put option, but the expression there is a little bit difficult, or different, I should say. Now, let's look at this question. Now, please make sure you are reading very carefully and identify the total value of the company as we are reading. Identify what the shareholders are going to get as we are reading through the question. Identify your redemption value of the bond or the loan as you are reading the question, so that you won't have trouble when substituting in your Black-Scholes formula. Now, I'll start reading here. They say the company is currently financed. So currently is at time 0. Financed entirely by equity with 100 shares in issue and no debt. The current share price is $1. Okay, now let's read. The company has total asset of 100,000 with volatility of 15% per annum. So these are your total assets for now. But let's continue reading the question. The company is considering raising 250,000 by issuing a 0 coupon bond debt with 5-year to maturity. So your little t here, if you're reading very carefully, is 0, and your big T, which is your maturity time, is at time 5. Okay, that is no big deal. They say the continuously compounded risk-free rate of interest is 3% per annum. Okay, now they say the company intends to set the redemption value, which is your L. Oh gosh, I wanted to highlight that. Which is your L, your redemption value, which is your L of the debt, such that the share price will remain unchanged under the Merton model. So by share price, what the shareholders of the company will get under the Merton model. Now they say, give the value of the company's asset immediately after issuing the debt. Now, currently, at time 0, the company has total asset, the question told you, of 100,000. But they want to raise 250, and they're going to do this by issuing a 0 coupon bond. So, in actual fact, the value of the company's asset immediately after issuing a debt will be the original 100,000 plus this value they want to raise, which they are going to do it by issuing a 0 coupon bond, which is 250, and there I'm going to get 350,000. Now, what is this? I know people usually confuse this. This is the total value of the company, of the company's assets at time 0. So this is your F of 0. It is not what the shareholders of the company will get. Because if you read very carefully, in the question, we have 100 shares for a current share price of $1. So what the shareholders of the company are actually holding at this moment in time, which is S0, what they actually have is 1 times 1,000 shares, which is $1,000. So that is the value of the shareholders, and we know that we value the shareholders as a call option. So this 100,000, which is 100 times 1, is the value of your call option, which is what the shareholders of the company are going to get. Obviously, we are not told the redemption value of this bond. And if you look at the second question, that is what the examiner is asking you. Now they say, calculate the redemption value of the debt using the Merton model. Now, if you've been listening to me, you know that that is your L. Okay, I'm using the Merton model. Now I've got the value of the shareholders, which I can use the Black-Scholes formula to value, but I'm missing L. Okay, let me set out my equation. I know that the value that the shareholders of the company get, the value that the shareholders of the company get can be valued as a call option. That is very important. But I know they are currently holding 100,000. So I'm going to say 100,000 is equal to, now using your Black-Scholes formula, that is equal to S sub T. But you know, since your payoff is the maximum of F of T minus L and 0, you know that your S sub T is the total value at time little t. In this case, it will be the total value of the company's asset at time 0. So I'm going to replace this by F of 0, and I'm going to multiply this by phi of D1, and I'm going to subtract L, which is K under the Black-Scholes formula, which is K, but K you can see in this payoff is replaced by L. So I'm going to say L e to the power minus 0.03 times 1 multiplied by phi of D2. And the examiner is looking for this L here. Now that is not going to be easy. Do you agree with me? Because really this question, this equation here in front of us is extremely difficult, and we cannot solve explicitly for L. So now we're going to do interpolation. We're going to do trial and error. We're going to do trial and error to solve this particular equation. Let me substitute my values before we do that. So what do I have? I have 100,000 being equal to the total value of the company's asset at time 0 is 350,000 multiplied by phi of D1. This phi of D1 also contains L. So really we can't simply just solve this equation by rearranging. We have to use trial and error. Minus what? Your L, which I'm looking for, e to the power 0.03 multiplied by phi of D2. Okay, now you're going to say to me, Gabriel, where do I even start with my trial and error? Do I start at 1? Do I start at 2? Well, you have to be reasonable with your starting point when you're using your trial and error. Really, it's a matter of being reasonable, because here, in order for the shareholders of the company to not get nothing, to get F of T minus L, do you agree with me that your F of T must be, at maturity, must be greater than your redemption value, must be greater than L? Now, right now, I've got my total assets being equal to 350, and I'm suspecting, just by looking at this, that your redemption value will be less than your total assets. So I'm going to start off by trying L is equal to 300. Okay, notice you can't just pick a value. You must be a little bit reasonable on what value you pick. Okay, this is really problematic, really, because I'm sorry. This is really problematic, really, because you have to start at the right point. So I've just shown you the reasoning what to do then. So I'm going to start off with L is equal to 300, and I'm going to calculate my terms. Now, if L is equal to 300, my D1 will be the natural log of 350,000 divided by 300,000 plus 0.03 plus 0.5 into your volatility, which is 15% squared, times your final time minus your initial time, which is 5 minus 0, which is 5. And I'm going to divide this whole thing by 15% multiplied by the square root of 5. Now, I'm going to punch that whole thing in my calculator, then find D1 at L is equal to 300, and then your D2 will be equal to D1 minus 15% times the square root of 5. So, in order for me to evaluate my Black-Scholes formula, I have to find phi of D1. So if you calculate your D1, you're going to have phi of 1.074507. Now, unfortunately, you don't have this X value in your table in order for you to find your cumulative distribution probability, but we use interpolation. Now, we don't write the interpolation steps here, because your calculation will be long and it won't be good looking, and it may lead you to panic. So just do that in your head, in your calculator, but do not write it down. So interpolating here, I hope you can interpolate. If you can't interpolate, please contact me on WhatsApp. So I'm going to have there 0.858699 interpolating. And your phi of D2 will be phi of your D2 calculated using this formula will be phi of 0.739097. Again, you don't have this X value in your table, so you're going to have to use interpolation. If you do that, you're going to get 0.770074.5. You take these and substitute them. So let me in fact highlight them and substitute them in your Black-Scholes formula here. And you're going to get the value of your call option, which is what the value, which is what the shareholders will get. If you do the substitution, you're going to get the value of the shareholders to be equal to 101,701.8706. You can see that is quite close to the 100,000 I'm looking for. So I'm doing good. Okay. Now I need another value so that I can interpolate the value of L. I need another value of the call option so that I can interpolate the value of L. Now, I want this value now to be below 100,000, because you can see this here is above 100,000. Now, what L will make the value of the call option to be below 100,000? So now I want to decrease the value of the call option. Now, the problem, often the problem here is, what do I do? Do I increase the value of L, or do I decrease it? So do I increase it from 300,000, or do I decrease it from 300,000? So what do I do there? Now, unfortunately, you have to remember how the parameters of the Black-Scholes model affect the value of the call option. Now remember, your payoff, the payoff of the call option and the value of the call option are directly proportional, which means, what does that mean? Now remember, the payoff of the call option in this case is f of 0 minus L. Now, if I increase L, that will decrease my payoff, decreasing the value of the call option. And yes, I want the value of the call option to decrease. So I can see here that I must try a bigger value of L from the 300,000 I've been working with. So I'm going to try now, I'm going to try L is equal to 340. You cannot go down from 300,000 because that will increase the value of your call option, and that is not what we want. So I'm going to try 340 now. Now, if you try 340, L is equal to 340. You're going to calculate your D1, but now your L will be 340,000, and your D2 will be D1 minus 15% times the square root of 5, which means your phi of D1, you're going to calculate using your calculator. You'll be sitting with your calculator in your exam. Your phi of D1 now will be equal to phi of 0.701342. Now you're going to use your orange book to find that. Unfortunately, you don't have this so many decimals, so you're going to use interpolation then. So interpolating, you're going to get 0.758457, and your phi of D2 will just be your phi of, you're going to calculate your D2 from your D1. So I'm going to get phi of 0.345932. Using interpolation there, you're going to get 0.642793. Now, you're going to take these. Sorry, this is your phi of D1. Now, you're going to take, let me use green. You're going to take these, your phi of D1, which you have calculated, and your phi of D2, which you have calculated, and substitute them again in your Black-Scholes formula, now with L equal to 340. And if you do the calculation there, you'll be sitting with your calculator. You're going to get the value of your call option to be 77, which is what the shareholders of the company will get, to be 77,352.548882. Now you can see that went too down from 100,000. It is too low from 100,000. But anyways, because you will be in the examination, from here you don't have to try any other values. You have to interpolate the value of L using the values of the call options you have just derived. But you must always make sure that the values you get is the value below 100,000 and the value above 100,000, so that your interpolation will be reasonable. Now, you're going to interpolate your L there. Obviously, I'm assuming because interpolation is a basic section in mathematics. I'm assuming you can do interpolation, so I'm not showing those kind of steps. Now, what have you got here? You have got a pair. if you think about it. You have got the call option, this value, for L equal to 340,000. And you have got your call option equal to this value for L equal to 300,000. So you're going to interpolate your L now, since that is what your examiner is looking for. And you're going to get your interpolated L to be 301,039.8935. Okay. So that is your L the examiner was looking for. Now you're saying, sure, this is a long calculation for 5 marks. Yes, I suggest you to be very quick when doing this, because it is quite a tedious calculation. Now, if you look at your exam report, the exact value of L is 302,582. And you can see we are not doing bad there. Now, for the purposes of this question and for the purposes of this exam revision, I'm going to use the exact value for the remainder of my question. Now, if you look at the next question, they say, now calculate the credit spread on the debt. Now, this is another standard result, because you know that your credit spread on the debt is given by the difference between the yield on your debt and your risk-free rate. Now, the examiner gave me the risk-free rate on the question to be 3%, but I'm missing the yield on the debt. Now, how do I calculate the yield on the debt? Now, the yield on the debt is actually how we calculate the price of what? The price of the debt. So right now I've got a redemption value of what? I said for the purposes of this exam revision, I'm going to use this. Right now I've got a redemption value of 302,582. If I discount that at my yield, right, I'm going to call it RY for 5 years, I'm going to get the price of this debt here. Now, the price of this debt here, it's not entirely clear from the question, but the price of this debt here is 250,000, because we are issuing a zero coupon debt in order to raise this, which we're going to raise it at time 0. Remember, I explained. So your price will actually be equal to 250,000. 250,000, and I'm sure you can solve this equation. It's quite a basic equation. So I'm going to find my RY to be equal to 3.82%. This is the redemption yield on the debt. Okay, so your credit spread will be given by the redemption yield on the debt and the risk-free rate. So I'm going to say 3.82% minus 3% to get the value of 0.82%. You see, that wasn't very difficult. Now, the next part of this question, they are saying, 1 year later, the company is struggling. The share price has fallen to 0.50, and the current value of debt has fallen to $50 per 100 of redemption. So that is a proportion here. This is a proportion of 0.5. So what they're actually saying, they are saying that the debt has fallen by this proportion here. Now they say calculate the proportion fall in the value of equity and debt. Now this here is the percentage the percentage change. Okay, and you know from your basic mathematics, how do we calculate the percentage decrease or the percentage increase? Well, if you remember, we take the final value minus the initial value divided by the initial value, and we multiply by 100. This is basic mathematics. So I'm either going to get a negative answer here, which will indicate a percentage decrease, or a positive answer here, which will indicate a percentage increase. So if you look at your question, they're saying calculate the proportionate fall in the value of equity. Now, the share price has fallen to 0.5, which means if the share price has fallen to 0.5, then and I've got 100 shares, what the shareholders now of the company will get is 0.50 multiplied by 100. This is the final share value of the company, what the shareholders are going to get, minus your initial. Remember, your original one was 100,000. So is it this 100,000? Yes, it is 100,000. Divide by your original one using the formula I discussed. So 100,000, and you're going to get there negative 50%, which indicate a fall. Okay, and the proportion the examiner is looking for is 50%. Now, as for the debt, now they are saying the current value of debt has fallen to 50 per 100 of redemption value. Okay, now there, so my final value of the debt, which is this year, will actually be equal to 0.5 times the current price of the debt, which is the one we calculated using interpolation, 302,582 minus the old one. Okay, the old one, which is the initial one, 250,000, and I'm going to divide this by the initial one, which is 250,000, and there I'm going to get a negative 39.5%, which indicate a fall. So these are your proportionate fall, your 39.5% and your 50% for debt and equity. Okay, that wasn't very hard. It requires some basic mathematics. Now the last question says, suggest why the value of the equity has fallen by proportionately more than the fall in the value of debt. Now this has to do with what the shareholders of the company get at maturity and what the bondholders get at maturity. If you look what I discussed earlier, you will see that at maturity, the shareholders will either get nothing, zero, from here, or the total value of the company minus the redemption value of the bond. And the value, what the bondholders get, will either get the total value of the company's asset or the redemption value. So, if you look carefully here, you will see that the debt ranks above the equity on the company's default. You can see that the bondholders will always get something, will either get F of T or L. So they will always get something, whereas the shareholders might get nothing. So might go away with zero. So the bondholders will always receive something at maturity. They may even receive the whole value of the company. So that is the valid reason as to why the value of equity has fallen by proportionately more than the fall in the value of debt. That is because the debt ranks above equity. The bondholders will always get something on maturity. Okay, so that was quite a question. Please make sure you are thinking. Do not be put off when you see something that you have never seen before. Just try to reason and think very carefully and see what you can do. All right, so let's look at our next question here. Now, our next question is based on the two-state model, and you will see it's not a very difficult question.